Let's recall and understand few things that is pre-required for your numericals. First thing first, we have a circle, and here we have the first quadrant, the second, third, and the fourth. Now, in the first quadrant, all the trigonometric ratios are positive. Here, sine is positive, sine and cosec is positive, tan and cot is positive, cos and sec is positive in the fourth quadrant. Angles are measured in anti-clockwise, which are considered to be positive. If it turns out to be clockwise, it will be negative. Now, with this in mind, we can talk about sine of minus theta. That would be minus 1 into sine theta. Because it falls in fourth quadrant, in its simplest form, this would be negative. Then here, this would be positive, because in fourth quadrant, cos is positive. And over here, in this manner, if I keep doing this, only cos and sec are positive in fourth quadrant. So basically everything else will be negative. Next, we are looking at understanding how to solve when we have sine inverse of an angle. So the final answer is minus 1 into sine inverse of an angle. Not exactly a proof, but a discussion. How do we end up with this? So we'll start off with let sine inverse of a negative angle be equal to theta. Now, taking sine on both sides of equation, so we end up with sine inverse of minus x is equal to sine of theta. So basically negative x is equal to sine theta. When is this possible? Well, we know that sine of an angle is negative in our third and fourth quadrant. But we know that sine inverse of x, the principal value, the principal branch. So principal branch of sine is where? Principal branch of sine of an angle is in your fourth and first quadrant, in between the space, right? So with all of this in mind, what can I tell? With all of this information in mind, I can tell that sine inverse of minus x has to be equal to minus 1 times of sine of x, sine inverse of x. Okay, so with keeping all of this in mind, we can come to this conclusion. Now, a similar set of reasoning can be given to cosecant inverse of minus theta, minus x. That will be minus 1 of cosecant inverse of x. Then we have tan inverse of minus x, which will be equal to minus 1 into tan inverse of x. Right? Okay, moving on, we have this scenario as well. Again, all of this has to be a commonsensical thing if you guys are familiar with the basics. So this would be minus cos inverse of x. It's getting subtracted from pi. So pi minus cos inverse of x. So let's look at the proof. Instead of with let cos inverse of minus of a value be equal to theta. Next, we're going to take cos on both ends, both sides of equation. So we end up with cos inverse of minus x, which is equal to cos of theta. And so here basically I'll end up with what? Minus x is equal to cos of theta. Now let's dig into the behavior of cos. Cos theta is negative in our second and third quadrant, right? And the principal branch is between 0 to pi. With all of this in mind, what can I tell? Well, if all of this has to be satisfied, cos inverse of negative x has to be pi minus cos inverse of x. Okay, so we have our similar set of reasoning to talk about secant, as you can see, secant and also cot. Secant inverse of a negative of an angle, we can get it by pi minus secant inverse of x. And then we have cosecant cot inverse of minus x, which is pi minus cot inverse of x. Right? So this would be your few facts and few things that we need to understand. So you have to copy pretty much everything. It's a revision. And this would be few new things of how to solve negative of negative value of your inverse trigonometric functions. I made a mistake. This is inverse.